Hey guys, I wanted to take a moment to thank you so much. Over the last probably couple of days, I've gotten 100 more subscribers and a lot of viewing time. I see that my VEX VR series has been pretty popular, and so I want to continue on with that. I just want a couple of things. If you have not subscribed, go ahead. That really does help me out quite a bit. And then also make comments, and it'll recommend it or suggest it more for others who are searching for things like VEX VR. So I really do appreciate all your help with that. And I just want to make sure that all the kids out there that are looking for something to do online have something that is an educational and enriching experience for them. And I think VEX VR is an amazing thing for that. Again, thank you so much. I really appreciate it. And I hope you enjoy this next tutorial. All right, here we go with, I believe this is part 6 of the VEX VR tutorial series. I'm super excited. You know, when I started this, VEX VR was still only a few weeks old. And a lot of us have been making suggestions about what to include. One of those suggestions that I had made was a console, and I guess I wasn't alone because they added it. We're also going to use the step-through feature, which is really cool, and just a few other things. They've added some more maps. That is super exciting because I didn't expect new maps this soon, and so hopefully we're going to get even more over the next few weeks. But the thing that they added was the dynamic wall maze. And so if you've watched all of the videos in this series, you'll know that they already have a wall maze. And so this is the wall maze. And they've also made it so that you can expand the playground to make it bigger. That's really cool for me. I don't know, I like that. You can really see a lot. Now they have a dynamic wall maze. And the dynamic means change, right? The dynamic wall maze, check this out. When I refresh it, the walls change. So in order to solve this maze, you have to write a program that no matter where the walls are, your robot's going to find the end of the maze. So let's get started. The first thing in solving a maze is to use, in any programming, is to use your past experiences. And I don't know if you've ever been in a corn maze, but I've been on a corn maze, and I can solve corn mazes super fast. All right, it's not a brag. It's just, you know, it's something that I've always been able to do, probably since I started playing video games and like maze type video games a long time ago. Okay. All right. So one of the ways to solve a maze is if you're walking through the maze or the labyrinth. Let's just say there's no lights at all. You're like in a, you know, damp sewer type maze. It's gross, and there's a minotaur chasing you. And we're going to be working with a maze that does not loop back on itself. We know that there is only one possible solution to the maze. So those are two things that we know. Let's say we've chosen to go right. If you imagine taking your right hand and kind of just touching the wall to your right, and go forward, and as soon as you feel like that wall move or turn, let's say it's a rounded maze, doesn't matter what kind of maze, just follow that edge of the wall wherever it may go, all right, all the way around. You are probably going to end up going a lot longer, a lot further than if you knew exactly, you know, go forward 5 steps, turn left, go forward 5 steps, turn right. But this way you will find the end. And so we just need to come up with an algorithm that is going to have our robot go forward and, you know, test the right side, and then go forward and test the right side again, and then go forward and test the right side. Keep testing that right side, and if it can turn and go forward, to do that. So what I'm going to do, I have a couple choices of sensors. I have left bumper and right bumper. So in those cases, the robot would have to touch the wall to sense it. And then I also have a front eye and a down eye. And I'm not going to use my bumpers. I just don't find them to be that reliable. I'm going to use distance in millimeters. I want to immediately turn right. And I got to be honest with you, figuring out this one problem took me longer than I really want to admit. You'll notice that the maze is open. It's like the entrance. And I wrote this program, and the stupid robot kept on going out of the entrance and falling off the thing for forever. So if you want to try this program on your own without using my tutorial, I would highly recommend that you do that. So like maybe pause it right now and give it a shot based on the information that I've just told you and see if you can figure it out. And then please continue to watch the video when you're done doing that to see if we came up with the same solution. I want to turn right 90 so that I can start to detect or sense the wall. And I do want to set my speed. So I'm going to go right, and then I want to go forward. I know that this map is all square, just like the other one, the other maze, the fixed maze. And so I know that each kind of square or block that I'm going through is 200 by 200 millimeters. However, I have to consider the location of the robot. The center of the robot is, or with the center of the sensor where it is, I got to add about 50 millimeters. Okay, I've just figured that out from trial and error. So I'm going to drive 250 millimeters. And let's see what that does. All right, so now I'm here. Now, I don't know, the robot doesn't know where it is in space. It doesn't know that that's the edge of the map. It doesn't know that it can't turn right. So it needs to check. Right? Because we're going to go forward. What if we missed an opening that was here? We don't want to keep going forward. We need to check our right side to see if there's an opening. So we're going to turn right by 90 degrees. And then we're going to sense. And really, honestly, I should have checked before we drove 250 millimeters if we could go 250 millimeters. So I need to go to the control and say if. And I'll say if I can, so sensing, we're going to say distance in millimeters, and then I need an operator because you notice that rounded distance doesn't go in there. So if distance is in millimeters is greater than 250, but I'm going to add some margin. So I'm going to say 260. So that means if it can see in front of it 260, at least 260 millimeters, then I want to drive forward for 250 millimeters. And so I'll go ahead and notice the map changed. I'll go ahead and play. And so it turns and then goes forward. But let's check. Let's keep there we go. So I'm going to turn right, and then there's going to be a wall in front of me. So I'm going to turn right, and then nothing happens. Perfect, because there's something in front of me. So at that point, if there is something in front of me, I want to turn back left and continue trying. So I'm going to say left. I could write this whole program right now, but I want you to kind of see the process. So let's just repeat that twice to see what happens. All right. So it's going to go through. Nope. And then go for. Okay. Now it turned left. Oh, because I had it repeat the left turn thing. Well, we only want it to turn left if it can't go right, or if it can't go straight. Yeah. Because it's going to turn right. And then if it can go forward, it'll go forward. If it can't go forward, we want it to go back left so they keep going forward. So in that case, we really want an if then, or if else. And the if else is nice because it allows you to say, hey, if I can go forward, else turn left. And then we can go back through the loop. All right. So let's see what happens if we do it that way. Okay, it can go forward, and then it still turns left. Let's refresh. So forward. Okay. The second time around, it couldn't go forward, so it turned left. That's what we want. Let's see. Okay, so the first time it's going to turn right. It won't be able to go forward, so it's going to turn left. So let's step through it. Remember I said we're going to use the step. Okay, let's go step. It's going to set the velocities and then turn right. Okay, now I've started out right. if you're asking why, I just figured out that's the only way that I've been able to ensure that the robot doesn't drive out of the maze by accident. Let's go to the next step. All right, it's going to run this repeat for the first time. So let's think about it. If the distance in front of it is greater than so it's not. So it should turn left. So I'll go forward. See, it jumped down. Turning left. Perfect. Now it's going to repeat again. So now it's going to check the value. Can it go forward 250? No. So it's going to skip and then turn left. So that's what we want. We want it to keep doing that over and over and over and over again. Okay, I figured it out. When I drive forward, I then want to check my right. So I always want to, if I can go forward, then check the right. If I can go forward, then go forward and check the right. If I can go forward and check the right. So if I can go forward is related to driving forward and then also turning right. So really, that's probably what I want right there. Let's try that. So I can go, I can't, so I'm going to turn. Hey, there we go. There we go. It's checking each time if it can turn right. And if it can't, then it turns left. All right. And then actually it just drives and wow, there it fell. Ah, it's dying. No. All right. I don't want it to die. So I actually want it to stop at the end. So rather than repeating this forever, I'm going to use a while. And so while the down eye, remember I said I was going to use the down eye, while the down eye detects red. No, while it does not detect red. So I'm going to find one of these operators. I'm going to select not. So while the down eye does not detect red, I'm going to have it repeat. And so once it says, I detect red, this is going to be false. So is it not detecting red? Yep. Okay, run the loop. And then it's going to check it again. Is it not detecting red? Yep. So run the loop. Is it detecting red? Yep, it's detecting red. Okay. Don't run that loop. And then it'll just do whatever it says right here. And just so we can see that it's jumping out of that loop, let's put like a little victory spin here. Let's say turn right for, let's do a 720. 720. All right, let's refresh the maze. So let's try this one. Ready? Boom. All right, we got it. Now I can run this, and I've tested this several times. I mean, probably over and over and over again on several different maps. And it's turned out, I mean, it solves it every single time. Now it's finding a really long route, but remember, it doesn't know. It has no clue how to do it. And I'm thinking of doing a part 2 of this maze where it actually records its spots. It records all the intersections and then can make a decision on how to get through the maze a second time faster without having to go through a bunch of other crazy dead ends and things. So I'm thinking maybe the next one will be like an intermediate, introducing how to use an array to store information. And then, we'll see where that goes. But I really hope you enjoyed this video. If you have questions, leave them down in the comments. I do respond to those. If you have suggestions or requests of videos you'd like to have recorded, again, I do also respond to those. So please do that. And I really, again, hope you enjoyed it. Thanks so much. Have a great day.